Assalamu alaikum, students. Today we shall start with the 2025 Feb March paper of paper 1-2. So without wasting a time, we shall start with the paper solution. The first question is a Boltzmann distribution for a sample of reacting gas is given with a label of activation energy over here. The activation energy is marked at this point, and then we have point X. The temperature of the sample of gases decrease, the shape, the distribution curve changes. So here we have this curve, and we have to decide that which new curve will give you the value of activation energy on this curve. So basically what we look at here is that there is now basically there is a decrease in the temperature. Temperature is decreased. So when the temperature is decreased, we have to decide what should be the new shape of this curve. So for this purpose, I will show you my notes on which you can find the new change in the curve. So from my notes, you can find that if we increase the temperature, then the curve moves to the right side and the peak moves downward. So the peak is moving downward, and as well as the peak is shifting towards the right side. So this is what you see like this, a shift towards the right and towards downward. So this is the change when we have a higher temperature, when we increase the temperature. In other words, if we reverse the temperature, which means if we decrease the temperature, then in that case, the peak will move towards the left side and towards a higher position. So it should move upward and leftward with a higher temperature. So considering that, we can now calculate from this graph that it should now move towards the left side. The temperature is decreased, so it should move to the left side and towards the higher position. It means the peak should be somewhere like here. I can write a rough diagram. It should move upward and it should be towards the left side. Now, in that case, we have to check what should be the value of this x, and again, we must understand that it should move towards the left side and it should move. So I'm going to draw a new curve here to get the picture clear. It should be something like this. It should move towards the left side and towards the higher position. And then the ending portion is basically something like that. It should move below the value of x. Why is it so? You can see here that if we look at this picture, we can see that when the temperature was increased, then the peak was flattened. We are supposed to find a value somewhere here, which is after the maximum peak value. It could be for this graph, it could be over here, for this graph, it could be over here, for this graph, it is over here. So you see that as I'm decreasing the temperature, the point is shifting towards the lower position and towards the left position. So this is the area where we have to locate the x position in our question. So if we decrease the temperature, so it is decreasing. The temperature is being decreased like this. So the x value is going downward and toward the left side. Similarly, you can find the same over here. The T2 has high temperature as compared to T1. So this is the value of EA. We have to find the value of x. So if the temperature is decreased and initially it was over here, then it should move to the lower position in the lower temperature. Move, the value has been shifted to the lower position. So we can conclude from here that in our question, the value of x must move towards the bottom position over here. So this is D. D is the right answer. where we are finding the new position of the X at lower temperature. So this is the correct answer. Now the second question. The crystals of the copper nitrate prepare by reaction of malachite with nitric acid, and the malachite formula is given in this MR. Along with that, we have the mass of malachite, which is added to this concentration and this volume of nitric acid. We have to determine the mass of the malachite, which is left unreacted when the reaction is completed. All right, so for this purpose, first of all, we are supposed to convert the values of malachite and nitric acid into the moles. Here we are given the mass of the malachite, which can be converted into the moles using the MR value of malachite. So first I will do that. I have the number of moles of the malachite to be determined. Now it is basically 12 divided by 2 to 1. Now the value of this part will come out to be 0.0453, 0.0543 mole. And then we have to find the moles of the nitric acid as well. So the number of moles of nitric acid is now equal to concentration times volume per 1,000. So 30 into 1.5 over 1,000. Now its value is basically 0.045 more. Okay, so we have now these moles. As mentioned here that excess of malachite was added. So we can clearly say that 0.053 is higher in value as compared to the moles of the nitric acid, which means malachite was definitely in excess. But how much was was left unreacted? For this purpose, I will simply do the subtraction. I have to subtract the value of moles of nitric acid from the malachite, which that will give me the amount of the malachite which reacted. So basically, the 0.0543, you can take the actual value because this will give me log answer, which I can quote here, since it would be 0.0542986, etc. You can use the whole value. It should be minus from here, from the moles of the nitric acid, that is 0.04545. Now this is the added amount of the malachite, added value of malachite, and this is the added value of the nitric acid, and it is a limiting reagent here, the nitric acid. So this would give me, the subtraction part would give me the 0.0009 92986 mole. Now this is the mole of the malachite uh, reacted amount of the malachite, or you can say it is the reacted value of malachite, because we do not actually know the chemical equation, and without that we will simply use this value. Okay, now you have to convert this mole into the mass using this formula. Rearrange this equation to find mass will be equal to number of moles into MR. So mass will be equal to number of moles will be 0.0092986 times MR. MR is 221. Now this value will come out to be 2.055 gram. Okay, now this is the value which we have got here. Okay, this is the value of the reacted. reactive mass of the malachite. We have to minus this value from the initially added value of the mass of the malachite which was added. So we have to take the difference 12 minus 2.055. This will give me 9.945. There's a problem here that we are not getting the required answer, which means this method was not basically the correct answer. So I'm going to erase this whole method and replace it with another method to find the right answer. Here we are now required to find the chemical equation for this reaction between the malachite and the nitric acid. So I'm going to construct the equation here. The formula for the malachite reaction with the nitric acid. So the equation should be constructed like this. We have the malachite. This is the formula for malachite, and CO3, it reacts with a nitric acid. Now this is basically forming the compound copper nitrate. We should know the formula of copper nitrate is CuNO3 2 or twice. Along with that, we do have the formation of the water because salt is reacting with the acid, so it should also form water. And along with water, we have this carbonate reaction with nitric acid gives the carbon dioxide. Okay, so this is the correct formula for the reactants and the products. Now balance this equation. So for balancing, we need to check the number of the copper atoms. There are two copper atoms on the left side and there is one copper atom on the right side. So I put two over here. Now copper atoms are balanced. Now check the nitrates. There are two nitrates here. So I put two over here. Now my nitrates are also balanced now. Now check the number of the hydrogen atoms. The hydrogen atoms might not be balanced. We have two hydrogen atom here and two four. On the left side we have four. On the right side we have two. So the balance stat. One more thing. The nitrates were not basically two. They were four because we have two nitrates coming from here and two from here. It means there are four nitrates. So I have to put four over here. Now all four nitrates are balanced now. Now to balance the hydrogen atoms, you can check that there shall be four hydrogen atoms from here and two from here, six. So to make six, I have to put three over here. Now balance hydrogen atoms are now balanced. You can check the carbon atom. There is one carbon left, one carbon on the right, and you can also check the oxygen atoms. We have two plus 3 plus 12. We have 17 oxygen atoms on the left side, and similarly on the right side, we have 3 to 6, 6 to 12, 12 plus 3 plus 2. So 17 oxygen atoms on the right side. So this whole equation is now balanced. Now from this stoichiometry equation, we can now use a ratio method to find the number of the moles of the malachite which would react. So basically, it should be the ratio between nitric acid and the malachite. According to balance equation, there are 4 moles of the nitric acid and there is 1 mole of the malachite. Over here, there is just 1 mole. All right. Now the calculated value for the nitric acid was come out to be 0.045 mole, 0.045 mole. And in that case, the reacted amount of the malachite would be X. So X would be 0.045 divided by 4. Now the answer for this portion will be 0.0 0.1425 0.125 moles. So this is the reacted amount of the malachite which we have calculated here. Now you will use the formula of N is equal to mass into MR. So mass will be equal to number of moles into MR, which means it is equal to moles are 0.11, 0.01125 into MR value is given, it is 221. This will give you the answer of 2.48625. 2.48625 gram. Now you have to subtract this value from the actual added value of malachite. So 12 minus 2.48625 will give you the answer of 9.51. So this is how you calculate the right answer. And previous method was wrong because it was not coinciding with any of the value. Our next question number 3, X and Y are the elements of the same group and their ionization energy from 5th to 9th are provided here. We have to check which of the elements X and Y are from the given options. So here we can see in the table that the change in the ionization energy while moving from 5th to 9th, we can see there's a large jump from 17,000 to 92,000. So it's a huge jump. And for element Y, we can similarly see that the ionization energy is jumping from 11,000 to 33,000. So again, there's a large jump from here. It indicates that both element X and Y have the 7th ionization energy to be the lowest. That indicates 7 valence electrons. So there are 7 valence electrons in both element X and Y, which means the element X and Y cannot be belonging to the noble gases, which have 8 electrons. Now, that means they must be present in the group 7A. Now, the next thing is that we have to decide which element X, which of these two have their different position in the group. Since we can see that Y has smaller value as compared to X, which means Y is below the group and X is above the group. So X must be above the upper element and Y should be the lower element. So X in this case is above, is upper element. So in option C, we can see that chlorine is upper element and chlorine is a lower element within a say group 7. So that's why the right answer becomes option C. Now the next question number 4. An ion with a charge of 2 negative contains 10 electrons and 14 neutrons. What is this nucleon number? So 2 negative, if the ion is containing 2 negative charge, it means these 10 electrons contains already 2 added electrons or 2 gained electrons. Out of the 10, the 2 electrons were gained, which means the protons should be 2 less, which means there must be 8 protons in this ion. And there are 14 neutrons. The nucleon number we know is the sum of neutrons plus protons inside the nucleus. So simple math is that we have to add 8 protons plus 14 neutrons. That will give you the answer of 22. So 22 is the correct answer. Now the next question number 5. The structure of hormone histamine is shown. Which row show the correct show the bond angle XYZ in the correct order? All right, so for this purpose, we must understand that when a nitrogen forms three covalent bonds, just like in ammonia, then the angle in this case is basically 107 degree. So 107 degree is supposed to be here. And why is that in which carbon is bonded with uh, four atoms through single covalent bonds, which means it is similar to the CH4 molecule. So in that case, it would give you 109.5 degree. And Z is that in which carbon is bonded through double covalent bond. So in that case, and it has three bonds, three atoms in its surrounding. And one of the three bond is basically a double covalent bond, which means it must be similar to the ethene or alkene, in which the angle is basically 120 degree. It is 120. Now I have all the three angles shown here. Now you can see that X is the lowest, Y is higher than X, and Z is the highest one, which means X is greater than X is smaller than Y is smallest than Z. So the only correct option in this question is A option. Now, the next question number 6. When an organic acid reacts with an alcohol, a reversible reaction takes place producing ester and water, and this much mole of organic acid reacts with this mole of alcohol, and equilibrium mole of ester is given. What is the value of KCl? So here we are not given the actual formula of the alcohol, of the acid, and of the ester. Means we can predict a generalized equation here. So I'm going to construct a generalized equation of the alcohol reaction with the acid. And we know as a result of this reaction, we will have the formation of the ester and of water. All right, now initially the amount of the alcohol which was taken was 0.3 mole, and at that time the acid was 0.4 mole. Now in that case, the ester produced was 0 and water produced was also 0. But uh, at equilibrium position, the amount of the ester has been mentioned, which is 0.2 mole, but no value of acid or alcohol or water is mentioned. We can infer from here that the amount of ester has been increased from 0 to 2, which means it has been produced. So if an ester is produced, then definitely the water is also produced by similar amount. So 0.2 mole of the water should also be produced. And at that time, the amount of the alcohol should be subtracted by the same value of one ester or one water, because we are basically taking the mole ratios. According to here, the mole ratio of alcohol to ester or alcohol to water are 1:1. One ratio for one for here, one for here. So we just take similar ratios for the ester or for the water. So 0.3 minus 0.2 moles of the alcohol should be left behind in the equilibrium condition for the alcohol. And similarly for the acid, it should be 0.4 minus 0.2 mole. You do not write 0.2 plus 0.2 here. You will be thinking like 0.2 mole of what asterisk produce and 0.2 mole of water are produced. So they should give you 0.4. No, you do not minus 0.4 from the 0.3 or from 0.4. That is not the case because we take the ratios. So here the ratios are 1-to-1 ratio. So that's why we take only 1 mole of either the ester or either the water. All right. Now, these are the values for the alcohol and the acid at equilibrium. So you just get 0.1 mole for the alcohol and 0.2 mole for the acid at equilibrium condition. Now we are supposed to find the Kc value, which is basically the concentration of the products divided by concentration of the reactants. Now here in this case, the value of the volume is not provided. We would only got the value of the moles here and know the volume of volume. Although we know that concentrations are basically the moles divided by volume, since no volume is provided, which means we can expect that the same mole is basically the concentration. So we will use the same values here. All right, so value for the value of the mole of the products for our ester, the ester value, and then H2O value in the product divided by the alcohol value and the acid value. In the data, they are multiplied. Ester and water at equilibrium were 0.2 times 0.2, and the alcohol in the equilibrium position is 0.1, and the acid is 0.2. Now you do simple calculation. 0.2 divided by 0.1 will give you the value 2. So 2 is the right answer. C is the correct option. Now the question number 7, information about two substances is given. And we have this information, we have to match this information with the substances P and Q. The substance P is basically showing good electrical conductivity when solid and when molten, and that's the basically property of the metallic because it can conduct electricity both in solid form as well as in the molten form. So here we can consider P to be giant metallic. Now the option Q says it does not conduct in any state. If it does not conduct in any state, it means it is neither metallic nor ionic. So these two options are excluded because they do conduct. Metallic can conduct in the molten form, in the solid form, and ionic can also conduct in the molten form. If not in solid, but definitely it can conduct electricity in molten form. So both options are incorrect. So the right options are simple molecular, which do not conduct electricity at in any condition. The second column of factor of adding water is totally matching with these other options and also the melting point. So that's why the correct option becomes option A, which has both the columns as ticked. Now, next question number 8. The excess of zinc reacts with HCl of this concentration of hydrochloric acid. The gas was tried, protected by this water pressure and pressure. Gas will use the gas as an ideal gas. What is the value of X? So we have to find X. The X we know is basically the volume of the hydrochloric acid. So for this purpose, first of all, we need to construct the equation. The reaction is between the zinc element and the hydrochloric acid. And after the reaction, it should produce the zinc chloride along with the formation of the hydrogen gas. The balance of equation we require to go over here. Now, chlorine and hydrogen are balanced. So it says that the gas occupies the volume of this much at this pressure and temperature. Now this pressure is basically equal to 180 M, and this Kelvin temperature is basically equal to 25 degrees centigrade. These conditions are related to room temperature and pressure. Okay, so which means the number of moles of the hydrogen gas which we can calculate should be 1.534 divided by the volume, molar volume of the gas should be taken, should be took at RTP at 24 TM cube. So 24 TM cube in the denominator. And now if you calculate this value, the answer will be 0.06391. 0.6391, and there are still more points after this. I'm just taking some values after that. This is the value of the mole of the hydrogen gas. Now I have got the value of the mole of the hydrogen gas, but I need to calculate the volume of hydrochloric acid, which means I need the mole of the hydrochloric acid. So I'm going to take the ratio between hydrogen gas and the hydrochloric acid. So according to balance equation, the moles of hydrogen gas were 1 and hydrochloric acid were 2. The calculated value of the mole of hydrogen gas is 0.06391. In that case, hydrochloric acid is X. So X should now be equal to 2 times of 0.06391. And when you put all the decimal points, the value should be near to 0.127833. We are still less decimal points here. This is the value of the moles of the hydrochloric acid. Now I have calculated the moles of the hydrochloric acid. Now I just need to use the equation. N is equal to C into V over 1000 for the hydrochloric acid. This is the formula to find the moles, but this is right for HCl. Now we have to find the value of volume. So for this purpose, I have to rearrange the equation. So volume should be then equal to N into 1000 divided by concentration. Now the value of volume is going to be number of moles are 0.127833 and multiplied by 1000 divided by the concentration, which we know is 2 mole per TM cube. So when you calculate this value, the answer will be closer to 63.916. 63.916. Now this value is very much closer to the option of D. D option. 63 point. Wait, my mistake. It is closer to the option 6. C. 63.916 is very much closer value to option C. That's the right answer. Now the next question, number 9. An aqueous solution of hydrogen peroxide is placed in a flask and decomposes. This is a reaction in which the hydrogen peroxide is composed. The total volume of the oxygen gas is this much, and in 90 seconds, the rate of the reaction is calculated using this equation. What is formula? What is the average rate of the reaction in mole per minute? All right, so for this purpose, we are supposed to convert the value of volume and the value of seconds into the moles and into the minutes. So this volume should be converted into the mole and this second should be converted into the minutes. For this purpose, we will do some calculations. So 180 is a cm cube, so it can be converted into the moles, and we should remember we are referring to the oxygen. The number of moles of the oxygen is basically now 180 divided by molar volume. Since the reaction is being done on room condition, which means that the molar volume should be 24,000 cm cube. So when we divide it by 24,000, then the moles will come out to be 0.0075 moles. All right, so this is the mole of the G side. Now we have done one part. Now the next second part is that we have to convert seconds into minutes. So it's simple. 90 must be divided by 60. to convert into the minutes, so it should be 1.5 minute. So it is 1.5 minute. Okay, now we apply this formula, but we are applying this formula for O2, not for H2. So mole is now 0.0075 and time is 1.5. Now value will be equal to 0.005 mole per minute. Okay, so we have calculated the rate, but in terms of O2, now we are supposed to find the rate in terms of H2O2. So that's what we were supposed to using the formula. So for H2O2 ratio O2, H2O2 is 2 moles according to stoichiometry, and O2 is 1 mole. And we're supposed to find the value of X when the moles of O2 were 0.005. So X will then be equal to 2 times 0.005. That is equal to 0.01 per minute. 0.01 moles per minute. So that's your final answer. That's like option D is the correct answer. Question for 10. Methanol is manufactured by reaction carbon dioxide and hydrogen. This is the equation which in what is the equilibrium between of the methanol. So we have to find the factor for increasing the yield of the methanol. So if we look at here, we can see this reaction is exothermic, which means that if we increase the temperature, that will increasing the temperature should increase the rate, should shift the equilibrium shift towards the endothermic side, which in this case is backward, because forward direction is exothermic, so increasing temperature does not increase the yield of the reaction. It does not increase the yield of the methanol. C says adding catalyst, it has no effect on the equilibrium shift. No effect on the equilibrium shift. No, not an answer. Then B says adding an excess of the steam. Steam is on the product side. So if we increase the value of the steam, uh, it should oppose this increase in amount according to Louis-Chatelier's principle, and it should move to the left side. That will not increase the methanol. Increasing the pressure says, okay, now if we look at here, we have 1 mole for the carbon dioxide, 3 mole for the hydrogen. So in total, we have 4 moles on the reactant side. Now on the right side, we have 1 mole for methanol, 1 mole for water, which means we have total 2 moles on the product side. So increasing the pressure means the equilibrium should move towards that side which have lower, it move towards that side which have lower moles, and lower moles means lower pressure. So on the product side, we have 2 moles. That's why increasing the pressure should move the equation towards the right side by increasing the pressure, because right side have lower moles. So that's why A is the correct option. Now question number 11, the equation for a reaction of KClO3 is shown. So here the reaction is a decomposition reaction in which KClO3 is decomposed into KCl and KClO4. And now we have to relate we have to match the 2 columns with the actual information. It says, is it a disproportionation reaction and what's the oxidation number? So for this purpose, we have to find oxidation numbers of all the elements in both sides. So potassium is +1, oxygen 1 oxygen has -2, so 3 times means it is -6, so which means the oxidation number filtering in should be +5. Okay, so it is calculated. Now in the product side, Cl is -1 over here and potassium is +1. And in KCl4, oxygen is -8 because we have -2 for one atom, +1 on potassium. Now it means that chlorine must have value of +7 on it. Okay, what we see here that chlorine is changed from +5 to -1 on one side, and from +5 to +7 in the other side. So +5 to from +5 to -1 is basically a reduction, and +5 to +7 is oxidation. So both the oxidation and reduction is there within one element. Choline is being reduced as well as oxidized. This is the definition for disproportionation reaction. So yes, disproportionation reaction is there, and we have already calculated the choline oxidation number is KClO4, that is +7. So +7 is there, which means the correct option becomes the option B. So option B is the correct answer. Now, question number 12. A student mixes 5 cm³ of 0.1 moles and new solution between 5 cm³, 0.1 mole HCl, and the temperature rises to 2.5 degrees centigrade. What is the enthalpy change? Okay, so for this purpose, we have to convert the values, and the information which we are supposed to find is enthalpy change, that is delta H. So delta H is basically minus MC delta T over N into 1000. Now here, the M is basically the volume. So minus volume is basically 25 of HCl and 25 cm³ of NaOH. So 25 plus 25. This M basically represents the mass of water, which has density is equal to, for water, the density is 1 gram per cm³. So that's why we take the volume as the mass. Then C is the heat constant, which you can find from data section. Data section indicates the C value is 4.18. I can show you on the screen. This is the data section which you are provided. So C value is given 4.18. Now back to the question. Then later we apply the temperature rise is basically the delta T. So you do not require to convert this temperature in centigrade to Kelvin. Do not convert into the Kelvin. Since it is a difference. So difference of Tf minus Ti is same for both centigrade and for Kelvin. They are same. So difference is same. So do not change the value into Kelvin. Then we write 2.5 over here divided by moles. So moles have to be calculated. We are provided equal value for volume and equal value of concentration for both HCl and NaOH. That means number of moles will remain the same. Number of moles of HCl will be equal to the number of moles of NaOH. None of them is limiting or excess. So it will be CV over 1000, that is equal to 0.1 into 25 divided by 1000. So that is basically equal to 0.0025 more. Okay, now we put value over here 0.0025 into 1000. Now when you calculate this, you will get answer in -209. Now we have two values, -209 over here, -209 over here. But since the value has been taken by dividing with 1000, that is used to convert joule into the kilojoule. That's why we divide it with 1000. So that's why the answer is kilojoule per mole, and as such, The correct option is A option. Now, question number 13. A carbon monoxide and methanol can react together to form ethanoic acid. So this is the equation. Carbon monoxide reacts with methanol to make this ethanoic acid. We have the enthalpy of combustion values for the reactants and the products. So we have to find delta HR. So in the case when they are all organic compounds or they are always the combustion values, we can simply use a shortcut for this case. The value for delta H would be enthalpy of the reactants, total enthalpy of the reactants minus total enthalpy of the product, simple formula. So here the reactants value is basically minus 283 for the carbon monoxide, which I'm going to put the values here. It is minus 283 here. And the other methanol minus 726. And for the product, it is minus 8741. So I put the values here. Reactant is now minus 283 plus the other reactant is minus 726, and then minus product is minus 874.1. So when you do the calculation, the answer will come out to be minus 134.9. So that's your correct answer. Minus 134.9. Now, question number 14. Copper reacts with nitric acid under certain conditions. The products are copper to nitrate, water, and oxide of nitrogens. And then we are given information that 3 moles of copper react with exactly 8 moles of nitric acid. What is the oxidation state of nitrogen in oxide? So from the given information, we will try to complete this chemical equation, balanced chemical equation. Copper is reacting with the nitric acid. And as a result, there is the formation of the copper nitrate, CuNO3 and water and oxide of nitrogen. Nitrogen oxide, we do not know the formula of that oxide. Oxygen could be Y and N could be X. We do not know the number of the atoms in that case because we have multiple options. We could have N2O5, we could have NO2, we could have NO. So these are different cases. Now we apply the other information, 3 moles of copper. So I will put 3 here. 3 moles of copper reacts with exactly 8 mole of nitric acid. So 8 should come here. Now we are given the moles of the reactant, but we have to balance it accordingly for the product side. If there are 3 moles of copper over here, then it means there should be 3 moles on this side to make the copper balanced. Now it is not balanced. So we now look at the hydrogen. So hydrogens, there are 8 on the left side. So make it 8. We have to put 4 over here. Now hydrogen atoms are balanced. Okay, now 3 moles of copper nitrate will give you 6 atoms of nitrogen. 2 times of 3 is 6 nitrogen atoms, which means there should be 8 nitrogen atoms. There are 8 nitrogen atoms on the left side, and there are 6 nitrogen atoms on the right side over here. So to balance a nitrogen atom, I will put 2 over here. So it is 2NO. Okay. Now, if it is 2NO, then nitrogen atom are balanced. Let's check about the oxygen. Oxygens are on the left side are 8 times 3 is 24 oxygen atoms over here, and on the right side 3 times 2 6 3 18 oxygen atoms here, 4 plus 4 over here, and then 2. Okay, now we can check it is also equal to 24, so which means oxygen atoms are also balanced. So all the atoms are now balanced, and this equation is balanced accordingly. Now we check the oxygen state of the nitrogen. That's what we were supposed to find. Oxygen state of the nitrogen. In that case, if the oxygen has -2, then nitrogen will have plus 2. So both will have 2 values on it. So this +2 means the right answer is B option. Now the next question, number 15. All the reaction and products of an exothermic reaction are gaseous. Which statement about this reaction is correct? So basically, we had to check the correct statement. It says that the total bond energy of the product is less than the total bond energy of the reactant, and delta H for the reaction is negative. This portion, the delta H of the reaction is negative. That is correct because the reaction is exothermic, for which delta H is negative. But for the first statement, we can check that um, delta H for the reaction is basically, if in terms of bond energy, the formula can be written as bonds broken minus bonds formed. That's a simple way of describing this type of enthalpy. And we know that broken are for the reactants. So bonds are broken in reactants and bonds are formed in products. For exothermic reaction, if delta H value is equal to negative, then in that case, the product side or bonds formed should be higher in value. It should be higher. And bonds broken and reactants should be lower. This value should be lower. Only that you will have minus sign. So it says the total bond energy of the products is less than the total bond energy of the reactant, so less is incorrect. B says that delta H of the reaction is positive, that is incorrect. D also says delta H of the reaction is positive, that is also incorrect. Now C says that delta of the reaction is negative, that is correct, and the total bond energy of the product is more. So more the bond energy of the product should be more. That's what we have seen here. It should be more. Only in that case you will have exothermic reaction to be negative. So that's why the C is the correct answer. Now the next question, number 16. Propene, HCN, hydrogen cyanide, carbon dioxide each contains 5 bonds, which molecule contains 2 pi bonds. Okay, so here we know that propene is basically a structure containing 3 carbon atoms along with one double bond. HCN has a structure like this, and carbon dioxide have a structure like this. Now, in propene, we have 1 pi bond here. In HCN, we have 2 pi bonds here, and both CO2, we have 2 pi bonds. So both HCN and CO2 have 2 pi bonds. So that's why this is the correct answer. A is the right option. B has only carbon dioxide as 2 pi bonds. C has only HCN 2 pi bond. D shows only one carbon, that is incorrect. It should also indicate CO2. So that's why A is the correct answer. Now, question number 17. Q, R, and S are consecutive elements fitted to the periodic table. Element R has the highest first ionization energy and the lowest melting point of the three elements. What are the identities of Q, R, and S? Okay, so we have to compare three elements together. And in that case, they have provided the information of only one element, that is element R. So R should be the one which has the lowest melting point and the highest fast ionization energy. So if we check the option that R must have the lowest melting point, we know that within the third period, P4 comes on the left side, then sulfur S8, and silicon is on the left of it in the periodic table. So in terms of the melting point, the silicon has higher melting point than acid, and acid has higher melting point than B4 in terms of the melting point. And in terms of the ionization energy, silicon has less ionization energy than the phosphorus, and phosphorus has less ionization energy than sulfur. So, so here, no, since we have to consider the exceptional point as well, that groups 6 elements have less ionization energy than group 5A elements according to the exception point here. That means silicon has less ionization energy than sulfur, and sulfur has less ionization energy than phosphorus because of the presence of the electron pair spin pair effect. Spin pair effect is observed in case of the group 6A. So that's the reason that phosphorus has the highest ionization energy and it has the lowest melting point. That's why D is a correct combination of these elements. So D is a right option. Now, question number 18, a reaction scheme for group 2 metal is shown, and we have this uh, pathway in which M reacts with oxygen to give X reacts with water, produce Y reacts with sulfuric acid. Which row is correct as M descends group 2 from magnesium to barium? Okay, so Z is basically the sulfate here. It is a metal sulfate of group 2. So it should be written as MsO4, just like we know about MgSO4. And Y is basically the oxide. So I can write it as M hydroxide. So in terms of Z, which is a sulfate, we know that going down the group, these sulfates solubility decreases down the group. So it should decrease down the group. And that's we know from the literature that solubility decreases because of the formation of the sulfates on the surface of the metal. That decreases its reactivity. On the other hand, hydroxides, we know that going down the group, the basicity or basic character of the metal oxide increases. So it increases down the group. So considering that, the correct option becomes option C. Question number 19. U, V, and W represent different halogens, and we have the table with 9 experiments in which the halide ions are basically reacting with the halogens to convert into the product form. We have to order them in the decreasing strength. All right, so for this purpose, let's start from the first part in which the U ion is basically added into the solution of U2. So no reaction is here. Definitely we do not react to similar halogens. But if you look at U minus reacting with the V2, it says U2 is formed. So what do we observe that U negative is basically converted to U2, and that indicates it is oxidized. When it is oxidized, it means it is working as a reducing agent. So it is reducing agent in this reaction, and it is also oxidized in the reaction with W2, which means in both of the cases, the U negative is oxidized. So if it is oxidized in both the cases, that indicates that it is a good reducing agent. So considering that U negative is the strongest reducing agent. Now, if we look at V negative, then it shows no reaction with U2 and no reaction with W2. It is no reaction, which means it is not oxidized. If it is not oxidized, it means it is a weak reducing agent. it is a weak reducing agent if it is not oxidized. So V is the weakest reducing agent, weakest, and W is definitely in between. So we can see that the only option with 3 ticks is the second row with the B option, the correct one. Question number 20. J is either MgCl2 or AlCl3. K is either SiO2 or K is either SiO2 or SiCl4. Now we have this pathway diagram in which we can see that J is being reacted with the aqueous sodium hydroxide converted into white precipitate, further reacted with excess to give white precipitate dissolve. We have to identify which of these J and K are the given options in the table. All right, so if let's suppose J is MgCl2, then we need to check the literature behind it. MgCl2 reaction with the sodium hydroxide along with the aqueous along with aqueous form. So we know from the literature that from my notes, if we look at MgCl2, that MgCl2 when added into water, it shall produce the Mg6 water molecules. In simple words, we can say that the hydrolysis of magnesium chloride in water will actually produce pH value of 6.5. So a pH of 6.5 solution is produced whenever we add MgCl2. Whereas in case of AlCl3, when it is dissolved in water, it shall produce a solution of pH equivalent to 3. So that's most stronger acidic as compared to the MgCl2. Now we come back to the question and we see that few drops of sodium hydroxide can react with J only if the solution of J is basically acidic. So yes, acidic solution can react with the sodium hydroxide. So it should form white precipitate. That is definitely the oxide form of the compound, or it could be the salt form of it could be salt. A salt is formed because of the base reaction with the acidic. But if we say that excess amount of the aqueous sodium hydroxide is added, it means that this salt should remain acidic, and that can only be seen in case of the MgCl2, in which the pH solution was equal to 3. That means this pH 3 solution can still react further with the sodium hydroxide. So that's why this would be only MgCl2, not Al. My mistake. I should write AlCl3 because AlCl3 provided a solution of pH 3. It could not be MgCl2 because MgCl2 solution was almost 6.5 pH, which can easily be neutralized when reacted with the sodium hydroxide. So MgCl2 reaction with NaOH aqueous will quickly be neutralized, but not the AlCl3 because AlCl3 requires much more amount of the aqueous sodium hydroxide to be neutralized. So it is basically the AlCl3 from the column of J. And about K, K says it is either SiO2 or SiCl4. Now the information provided is misty white films and a white precipitate in a solution with pH less than 7. Okay, if we check direction of SiO2 with the water, I can show you again from my notes. If we add SiO2 into the water, then the information provided is that it is insoluble. It does not dissolve in water and the pH remains 7. So that's about SiO2. But if we look at the SiCl4 dissolved in water, we can clearly see that it gives off the HCl fumes and the pH solution is almost 2. So this is the compound which is going to be our answer in our question, because pH value should be less than 7 and should give white misty film. That is because of the HCl. So if you need these notes, you can contact me on my WhatsApp number or you can reach me out in my on my Instagram or email. I can provide you the whole AS chemistry notes along with the topical, solved, and unsolved. Okay, so SiCl4 is a correct option from the column of K. That means the correct option becomes A. A is the right answer. Now, the next part of this paper will be completed in my next recording. So till then, stay tuned and subscribe to my channel and share with the others in your circle. Till then, take care and Allah Hafiz everyone.